Okay, so the quote question I did today was called perfect correlation. It's a medium probability question, which was pretty helpful, I found. Suppose X and Y are perfectly correlated. So X and Y equal to 1, sigma Y is greater than sigma X. Find the correlation of X plus Y and X minus Y. So basically what we're trying to find is here. This is what we're trying to find. We're trying to find this, right? Correlation between x plus y and x minus y. So we can write this as the covariance of these and then the sigma of each. So that means that we're going to find the respective of covariance and sigma of that. So I'll kind of walk through some of the rules I learned today. Covariance, if you have such a form, ax plus by, cw plus dv, what we can do is there's this bilinearity property where you can just put each one together. So like AC covariance xw, AD covariance xv, BC covariance YW, and BD covariance whatever is remaining. B and D are Y and V. And then also, yeah, basically what it does is like the constants gets pulled out to the front, and then the variables pair up in every possible direction. Also, we have covariance of x is equal to sigma of x squared. So that's pretty straightforward. We're going to start the calculation. So since we know we're trying to find this thing over here, we're going to have to find these individually on the right. We're going to first start off with covariance. Covariance of x plus y, x minus y would just be the same rule we just talked about here, bilinearity. So we kind of were able to expand it out to this form. And because covariance is symmetric, so covariance of xy is equal to the covariance of y and x, right? So then the middle terms kind of cancel out. And we know that just earlier I talked about covariance of the same variable is just that, its variance. So we just get covariance of this is just equal to sigma x squared minus sigma y squared. And then next we have to calculate the standard deviation of sigma x plus y and sigma x minus y. So we're going to start off with the variance equations we know. Variance of x plus y is equal to sigma of x squared, sigma of y squared plus 2 covariance. And since x and y are perfectly correlated, so we know that the covariance is equal to 1 times sigma x times sigma y. So we just plug this in, take the square root of that, and we get sigma x plus sigma y is equal to this. And then for x minus y, it's the same thing but minus 2 covariance. And then we get this. And since it's squared, we know that sigma of y is greater than sigma of x, and we need the term to be positive. So we're going to get sigma y minus sigma x instead. And then when we combine these together, we just plug back the terms we just found. This is the sum of squares, difference of squares, so we kind of get this. And then we simplify to that. We then pull out a -1 from the factor, and we get our coefficient is -1. Okay, cool. That's it for today. I think the major thing from this problem is knowing just like to find how to find the covariance and using the variance formula, and knowing that covariance is bilinear and the covariance of the same variable is just its variance. Cool.